All right, so everybody's wondering why in the world do I have that picture right there? Well, it has to do with our lesson today. All right, I tried, if you look at the last class's video, which I'm not expecting you to do it, but I kind of tried to draw a picture, but I thought, you know what? I'm just going to go out there and take a picture. Shouldn't take that long. And to kind of explain what we're going to do. All right, so let's see if I can even write on this. Probably can. Yep, there we go. All right, so we're talking about inequalities, and this is going to talk about that first theorem that we're going to do, okay? And it's just a visual representation on what's going on. All right, so I remember a bunch of years ago when this was just all grass right here. I remember when the trailers weren't even there, okay? I don't know how big that tree was. I don't remember that, but anyway, it used to be there was just a sidewalk here and here. Actually, before they built this, Mr. Pusey actually built that thing right there. There were the trailers, but before this little pathway was built, what do you kind of guess? You weren't here, okay? I don't even. Yeah, it's been a while, so you're probably just a really little kid when they built this thing right here. But why do you think they built this? Well, this was all grass right here, and what's that? Okay, well, it's not necessarily perpendicular, but why do you think they built this right here? They built this after they built these sidewalks. And it used to be all grass here. It used to be all grass. What do you think people were doing? People were walking through the grass. Exactly right. And Josiah, you're on the right track, okay? It wasn't exactly what I was asking, but I understand what you were saying, and you're absolutely on the right track of why we're doing this, okay? But people would walk on the grass over here, all right? And they used to try to tell you, don't walk on the grass. They put little tape, there, like whatever, that yellow tape where you're not supposed to pass it or whatever. Don't walk on the grass. It's messing up the grass. Well, they decided that didn't stop the kids from walking in the grass. Why in the world would kids walk on the grass when they got a perfectly good, nice, wide sidewalk where you could walk this way and then you could walk this way to get to there? It's a shorter distance, exactly right. Okay, so let's do this in a different color. I don't know if that blue will show up or not, but let's give it a shot. So, watch, you took a shortcut, right? Which is fine, all right? It happens all the time. You go to college campuses. I saw a video or something where they showed all these college campuses where they showed all these pathways through the grass, and they weren't supposed to be walking on the grass. And then the school decided, well, this is where everybody's going to walk, so let's just put a sidewalk there, okay? So this is a thing, all right, that happens all over the place, all right? Because people know. People that don't even know geometry know that if I walk straight from here to here, it's a shorter distance than going up to this sidewalk and then down to this sidewalk to where you're trying to go. Do you agree? Did you have to know any geometry? No, you wouldn't have to know any geometry. Anybody, it's common sense, right? That you know that going from one point to another just straight there is a lot shorter than going up and then going down like that. Make sense? All right, that's what this theorem is doing. This theorem says, and I'll read it to you. I think I wrote it down in the other class, but I'm not going to write it down here. I'm just going to say it. I'll take it little chunks. So everybody listen, pay attention, okay, so you hear what I'm saying. It says the sum of the lengths. What does that mean, sum? The sum. Overall, when you do what? When you add them up. Okay, when you add them up. Very good. Okay, so it says the sum of the lengths of any two sides of a triangle. All right, so if I added up this red one and this red one, or I could add up this blue one and this red one, or I could add up this blue one and this red one right here. It doesn't matter. If I add up any two sides of a triangle, it doesn't matter what your triangle looks like. It doesn't have to be a right triangle, doesn't have to be acute or obtuse, doesn't matter. Any triangle, if I add up any two sides of that triangle, what is it going to be compared to this one? So if I added up this red one, call it A, and added up this red one up here, call it B, what has to happen, or if I compare the sum of those two, what is it going to be compared to this blue one? It's going to be greater than, okay? And that's exactly what this theorem says, okay? It says The sum, add up, right? If I add up A plus B, right here, that's going to be greater than the third side. What do you want to call the third side? Let's just call it C, all right? Everybody see that? So I could take any two sides. It doesn't make any difference. I could add up A plus what? C. And that's going to be greater than the third side. What's the third side? I got an A and a C. What's the third side? It would be B. That's correct. All right? Or I could add up what? I already added up the A a couple times. Yeah, the B plus C. Good. Okay, so if I added up this B and this C, what is that going to be compared to A? It's got to be greater than A. You with me on that? So I could add up any of the two sides. And if I add up any of the two sides, it's always going to be bigger than the third side. And that's a pretty important theorem. They call it, I'll write down the name of it, the triangle inequality. All right, why inequality? Because we're comparing and we're talking about being greater or less than, okay? So we call it an inequality theorem. All right, so it's the triangle inequality theorem. So how are we going to use this? Well, I'm glad you asked. So what we're going to do is we're going to give you a triangle. What if I give you a triangle with lengths 3, 4, and 5? Okay? Let me say this. We don't know it's a triangle just yet, but I know I got sides 3, 4, and 5. I got lengths. I got one length is 3, one length is 4, one length is 5. Can I make a triangle out of something with sides 3, 4, and 5? Well, yeah, I could make a triangle out of any three sides, right? Wouldn't you think? You would think so, but let's think about it. What did that triangle inequality theorem say? It says the sum of any two sides has to be bigger than the third side. All right? You with me? So let's take any two sides. Which ones do you want to add up? 3 and 4? Okay, so 3 plus 4 is what? Now, here's how you decide if it's a triangle or not. You hear me? How do I know if this is a triangle? If I add up any of the two sides, it has to be greater than the what? The third side. So if I added up 3 and 4, that has to be bigger than what? Than 5. Is 7 bigger than 5? Yeah, it is. Okay, so check. Yes, it is. What about the other ones? Let's add the other two together, 3 and 5. So 3 plus 5, what's that equal to? 8. 3 and 5, is that bigger than the third side? Yes, so that works. What's the other two sides that I haven't added up yet? 4 and 5, right. So what's 4 and 5? That's 9. And 9 is what? Greater than the third side, 3. Is 9 bigger than 3? Yeah. So if all those three things are true, is this a triangle? Yes, it's a triangle. Can I take any three numbers and make a triangle out of it? Think about it. You guys thinking? Can I take any three sides, any three lengths, and always be able to make a triangle out of it? Okay, let's think about it. What if I said 3, 4, and let's say 9? What's the theorem say? I could take any two sides, add them up, and it has to be what? Greater than the third side. Does that work here? Because 3 plus 4 is what? 7. Is 7 greater than 9? Of course not. 7's not bigger than 9, okay? So, look, that doesn't work. So guess what? This is what? Not a triangle. All right? So you cannot have sides 3, 4, and 9. So you cannot take any sides at all and make a triangle out of it, okay? They gotta fit a certain form. And what is that form? If you take, now look, I went through all three of these, didn't I? If I take the biggest one plus any of them, that's always going to be bigger than the third side. Would you agree? Okay. So what I do so that I don't have to worry about doing this, I don't have to worry about doing this, what do I take? I take the two smaller ones, okay? And if the two smaller ones added up are bigger than the third side, then yes, it's a triangle. What about this? Let's do 5, 6, and 9. Is that a triangle? That's the question. Is that a triangle? Yeah, take the two smaller ones, which is what? 5 and 6, and you add them up, it's 11. Is 11 greater than the third side? Yes, it is. So that's a triangle. Agreed? What about this? What about sides 2, 6, and 9? Is that a triangle? Why not? 2 and 6. We go 2 plus, let's just do it in our head. What's 2 plus 6? Okay, these two right here. 2 plus 6 is 8. Is 8 greater than 9? 8's bigger than 9. No, it's not. So 8 is not bigger than 9. So, is this a triangle? No, it's not a triangle. What about this? What about 4, 5, and 9? Is that a triangle? That's right, it is the same. 4 plus 5 is what? 9. Is 9 greater than 9? No, it's not greater than. It's actually equal to. But what does the theorem say? It says it's got to be greater than. Okay? This is not greater than, so this is no. So you cannot have a triangle with sides 4, 5, and 9. All right? Think about that. Look up here. What if I had... Now, I don't know how many inches that is or whatever it is, centimeters or anything, but let's just say it's 9. Okay? You with me? And what numbers did we use before? 5 and 4, right? So check this out. Watch. So 5, I'm just guessing. It's an educated guess, but it's probably, well, halfway be 4.5, right? So let's say that would be 5. Okay? So let's say that is 5. And let's do this in a different color. Watch this. What do you think it is from there to there then? If that's 5, what do you think this blue one is? 6? It's what? Yes, quattro. All right? Now check this out. Can I make a triangle with these 3 lengths? Now we already know by the theorem that you can't, but let's just visually see if you can or not. So if I took this here, and I took this here, this wasn't, I think I tilted it a little bit. Okay, everybody see that? That's 5, that's 4. But watch this. As soon as I start moving it up, let's put this end on. What happens? I'm trying to grab this blue one without grabbing the red one. Hold on, there we go. Look, what happens? Look at that gap. It's going to be short, isn't it? All right, think about it. Here's an example. I think, let's go 2, 1, and Deshaun, grab me one of those markers up there, real quick. Nope. Thank you. All right, check this out. How many is that? 3. Okay, now watch. This is, everybody look. If you're watching this on YouTube, you can't see, sorry, but what's this one up here? How many? 2. And what's this one? 1. That's 1. Okay, now if I put them together, they would equal, correct? 6. But watch what happens. Now I'm going to try to do this. Watch what happens. In order to make a triangle out of it, this is going to have to go up a little bit, right? And that's going to have to go up a little bit. So look in between. There's a gap. The more I go up, the more the gap is. Would you agree? Yeah. So the only way, if they're equal to each other, there's no way I can get a triangle out of this, because as soon as I lift one up just a little bit and lift the other one up just a little bit, there's a gap, and it's not a triangle, is it? Would you agree?
I don't know, like,
Deshaun, give me one more. Well, 180. Watch. Thank you. So look. Right. So look. This can keep going up, 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 up. It can even go this way, this way, this way until it gets to 180 degrees. Right? If that's 180 degrees, I can't have one angle inside of a triangle being 180. Why not? Because all three have to add up to 180, right? So I could go up to like 179. You see that? But I can't go to 180, then I wouldn't have a triangle. It'd just be a straight line, wouldn't it? All right? But it can tilt up a little bit like this. So watch this. What if, how many is that? That's 4, right? So can I have a triangle with sides 2, 1, and 4? I just want to show you visually why you can't. This is a lot easier to see. Because look, there's 2, there's 1. Is there any way that you could have a triangle with those lengths? No. So you can't have a triangle with lengths, what did I say, 2, 1, and 4? Let's do the math on it, and let's see why. 2, 1, and 4, 1, 2, and 4. We'll just go in order. How do I know by that theorem that I cannot have a triangle with those lengths? I add those up. 1 plus 2 is what? 3. Is 3 greater than 4? No, it's not. So no, you cannot have a triangle like that. So you don't have to have all these markers, right, to figure it out, but that should help you make a little bit of sense out of it. Does that make sense? All right. So that's the kind of stuff that they're asking you. Let's do a little bit more. Probably use those markers again. Now, this one's way too long for me to write out, but I will show you the picture, and that should make some sense. Let's pay attention, guys. You should be writing this down. There's nothing that funny going on. All right, so I'll tell you what. I did this in the last class. I should have known better. Let's make this one a color. Just be a lot easier to deal with colors. And we'll make this one green. Okay. Now watch what I'm going to do. I'm going to copy and paste that. Put it over here. But I'm going to change one thing. Everybody watch. I'm going to take this angle, and I'm just going to change the angle. Now it moves it away from the triangle, but I'll move it back. Did I change the length of that green one? All I did was just tilt it. Okay? Everybody see that? So that means, everybody listen, that means that this side and this side are equal to each other, right? I just copied and pasted. Agreed? I didn't move it or anything. I didn't do anything to it. Now this side, I did change the angle of it, but did I change the length of it at all? Did not change the length of it, okay? Now look at this angle then. This angle right here, let's do a different color. What do you think might be true about this angle compared to this angle? Yeah, this is obtuse, this is acute, but let's talk about the inequality part of it. This is what to this? It's greater than, that's right. And in fact, what I'm going to do is I'm going to put 2 arcs just to show you that the one with 2 arcs is bigger than the one with 1 arc. Is that all right? Just the easy way to show you, all right? So this angle is bigger than this. Now, here's what we're trying to show. Got a lot of people not paying attention. Don't know why. Everybody look up here. Eyes up here. Okay, so I've got one side equal to another side. I got a second side equal to a second side. But this angle is not equal to this angle. Would you agree? If they were equal, then I'd have congruent triangles. But they're not congruent. Watch what happens. When I connect and I make that third side, what I want you to do is I want you to give me a comparison between this side right here and this side right there. That's right. So the one on the left is longer. The one on the right is shorter. You with me on that? Now why? How would you know just by looking at it? Maybe I draw the triangle so close that you can't really tell that that one's longer than that. I mean, you can just eyeball this and look at it and say, yeah, that's bigger than that. But sometimes they draw the triangles so close to each other you can't really tell the difference. Well, it's this. I'll show you. This one is the bigger angle, correct? So this side is opposite the bigger angle. You see it? This side is opposite the what? The smaller angle. So the side opposite the bigger angle has got to be what? bigger than the side opposite the smaller angle. We'll just call that small. You see that? So that's why geometrically it works, okay? So you don't want to just, again, on a quiz or a test, it might be hard to tell which one is bigger, which one's smaller, just by looking at it. You're not going to take a ruler out and measure it, because sometimes these pictures are not drawn to scale. What does that mean? It means I may say that's 10, but I might say that one's 12. It's not drawn to scale, is it? Because that one looks bigger than that. Agreed? All right, so sometimes they do that. So you got to go by the geometry. The geometry says if you have this side equal to this side and this one equal to this one, by the way, I shouldn't have just put one tick mark. I should have put two, okay? Then the side opposite the bigger angle is bigger than the side opposite the smaller angle. They call this the hinge theorem. I'll show you why. I don't really like that they call it the hinge theorem. I understand why they do. All right? I want to show you with these markers again why they call it the hinge theorem. We've kind of talked about it already. Let's go 3. And let's go 2. All right. So everybody look at here. So all I'm doing is basically what I just did right there, but you can kind of see it a little bit better. Everybody watching? So I've got this side and I got this side. So if I made that a big angle, see down here in the bottom, see I'm pointing right there? That's a big angle, isn't it? Okay. As I make it smaller, I want you to look from here to here at that third side. I don't have 3 hands. If I had 3 hands, then I could show you, all right? But watch. Do you see the third side? Right? It's invisible right now, but just think about it. All right? You got a third side right there. What happens to that third side as I make that angle smaller? It gets shorter, 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 shorter. You see that? Okay. What is this acting like? This is acting like a what? What's the name of the theorem? It's acting like a hinge, right? Hinge on a door, right? Just goes back and forth. What does it do? It changes the angle of the door, doesn't it? To the wall, right? So that's acting like a hinge. You see it? That's why they call it the what? The hinge theorem, because that's what it's doing, right? As the angle gets bigger, that third side gets bigger. As the angle gets smaller and smaller and smaller, that third side gets smaller and smaller and smaller. You got it. I think we got that covered now, don't you? Yeah. Okay. You could also do it the other way. Watch this. Oh, here, let me tell you this first. And get rid of all this. We'll keep that right there. All right. We also have a thing called the converse of the hinge theorem. Converse of the hinge theorem. It's kind of like what we just did, except, if I can spell, there we go. All right? It's kind of like we did, except I don't know that this angle is bigger than this angle just yet. But I do know that this side is bigger than this side right here. In fact, let's give it some letters, make it look a little bit more like you're going to see in the book. All right, so we'll call this call this ABC, call this DEF. Okay, and here's what they tell you. They say if line segment AC is greater than line segment DF, then what you need to do is compare angle B to angle E. I'll put a little blank right there, okay? We'll fill in the blank. Everybody's looking? Got like 3 of you. So if AC is bigger than DF, so if this one, now this is not what the book does, but this is what I do sometimes. I'll put a big old tick mark right there, and I'll put a little tiny tick mark right there, okay? So that's bigger than that. You okay with that? All right. So if this side is bigger than this side, tell me something about this angle B compared to this angle E. What do you think? B is what? It's the same? B and E? Remember, AC is bigger than DF. All we're doing is going backwards of the hinge theorem. It's the converse of the hinge theorem. So if this side is bigger than this side, then what? This angle, it's bigger than this angle right here, okay? If the two sides are unequal, right? So if this one is bigger than this one, then the side opposite, the big side, is going to be bigger than the side opposite the what? The small side. So what's angle B? Angle B is what? Greater than, greater than angle E. And that's your answer right there, greater than. You guys catch that? It's basically the converse. It is the converse of the hinge theorem. The hinge theorem said what? That angle B was bigger than angle E. That means AC was bigger than DF. That's right. It's saying instead of knowing the angles, this time we know the sides. The hinge theorem, we knew the angles, right? I changed the angle, and then we could tell something about the side. See how they're kind of the same, but different. All right, let's do an example. Might have time to do 2 examples. I only did 1 in the last class. So hopefully we'll be able to get 2 of these done. All right, so let's draw this thing. Be a good idea if you drew it too. All right, if you take notes, it makes it so much easier to stay awake. I know this is not the most exciting stuff in the world to you. I get it. But we still got to learn it. All right, there's a lot of things in this world that are not always super exciting, but you got to do it. But I think this is kind of interesting. Watch, I'm going to put some letters in here. K, L, M, N. And I'm going to put some numbers in here. I'm going to say that length is 7 and this length is 5. And I tell you that this and this are equal to each other. All right, so here's all the information I give you. This could be a quiz question, a test question, definitely a homework question, and so forth. It's not that funny, just saying. So let's take a look at this. What do I have? I've got, let's do this in red. What do I know about this side? So I've got a side and a side that are equal, and then I got 2 sides that are unequal, just like I had right here. Right here, I had 2 equal sides, right? The 2 yellow ones, the 2 green ones. So I had 2 equal sides, and I had 1 side that was not equal. That's the same situation I have right here. Everybody see it? I got this side and this side are equal. This side, this diagonal right here, is equal to that triangle, and it's equal, same thing on that triangle. So what am I doing? I'm comparing the sides, and that's going to help me compare the angles. So the question is, here's the question. It says angle KNL blank. All right, the blank means you say, is it less than, greater than, or equal to? You're going to compare. That's what the word in the problem says. Compare these measures. Compare angle KNL to angle MLN. Angle MLN. All right, so we got to find these angles. Let's find the angles. KNL, where is it? There's K, there's N, there's L. So which angle are we talking about? That one right there, okay? Now, I want to compare it to MLN. There's M, there's L, there's N. So what's my angle? It's this one right here, okay? So they're not equal to each other, but I don't know which one's bigger yet. But let's take a look. How do I know if this is bigger than that? If you look at the picture, it's almost impossible to tell which one's bigger. Would you agree? You can't just look at it and say, oh yeah, that one's definitely bigger. You can't do that. No, you can't. So look, what we have to do is look at the numbers they give us. They give us this as 5, and they give you this as 7. All right? So look at the angle opposite 5. You see that one? So that angle is opposite 5. This angle is opposite what? 7. So 5 is smaller than 7. So this angle right here is what? Less than this angle right there. Okay? This is KNL. So KNL is what? Less than this angle up here. And that's how you tell it. You look at the sides. This side is smaller than this side. 5 is less than 7. 5 is opposite this angle. 7 is opposite this angle. So now I can compare the angles. This has got to be smaller than this one. Why? Because it's opposite a smaller side. Okay? This angle's opposite 5. This angle's opposite 7. So this has to be smaller than this. And that's why we put less than. And that would be your answer. Let's do one more. You getting this? Let's do another one. You only got 2 minutes. We'll have time just to do this one and nothing else. All right, so what if I had that come to here and I had this one, come to here. All right, let's put some letters in here. This is V, U, W, X. They tell you that these two, well, they don't look equal, okay, I'll tell you right now, but that's okay. This probably makes things a little bit better. So they tell you this is 53 degrees right here, and they tell you this is 37 degrees right here. And what they want you to do is to compare these two sides. UV, that's a U, V, compare it to VW. All right? Here we go. Where's UV? UV is this one right here. Everybody see that? And then VW is this one right here. So compare this one to this one. I'll tell you right now, this is not drawn to scale. So you cannot just look at this and say which one is bigger, which one is smaller. There's no way. But what are you going to do? You're going to look at the angles. So look at the side that's opposite this angle. UV is opposite 53. Well, VU is opposite what? 37. 53 is what compared to 37? It's greater than. So UV must be what? Greater than VW. And that's your answer right there.
Is it always going to give us the
okay. Yeah, they'll give you enough information to be able to do that. Okay. Hold on a second, and It's 13 to 16 and 18 to 25. Good. 13 to 16 and 18 to 25. Well, you can just look at section 5.3. If you go to section 5.3, there's only one homework section. To 5.3, just find the numbers. Okay? I don't want this now. I'm collecting it tomorrow. And cut the edges off.